So there are some useful derivatives you need to remember, but let me just start from the basics. So the simplest differentiation problem you can come across is where you have a function of the form y is equal to ax to the n. If you want to find dy dx, the result is an times x to the power of n minus 1. Well, similarly, the same way you remember this is the same way I'd like you to remember these derivatives. So we have some trigonometric functions here. You can easily identify the sine, the cosine, and tangent. So you have the sine of x. Well, the derivative of the sine of x is the cosine of x. Not so hard to remember. The derivative of the cosine of x is equal to minus the sine of x. So the tricky thing here will just be to remember the minus sign. It's very easy to forget, and it makes a big difference. The tangent of x. When y is tan x, that's what we're saying here, by the way, because this is the column for y, when y is the tan of x, the tangent of x, dy dx is equal to sec squared x, which is the same thing as sec x, the secant of x squared, and if you recall, the secant of x is the same thing as 1 over the cosine of x. So this is the same thing as this. So try to remember this as well. Of course, everything. And then this looks a bit messy, but it's actually simple. So this says the sine of, if y is equal to the sine of a function of x, dy dx is equal to the derivative of that function times the cosine of f of x. Now, an easy way to remember this is to remember that the derivative of the sine of x is the cosine of x. So the derivative of sine of f of x has the cosine of f of x in it. This is just a technique for remembering it. So if you differentiate sine x, you get cos x. So differentiating sine of a function of x gives you the cosine of a function of x, but you just need to remember to multiply by the derivative of that function. And the same thing applies here. If you have the cosine of a function of x, if you differentiate it, it's going to be minus sine of the function of x, but times the derivative of that function. Similarly, if you have the tangent of a function of x, differentiating it is going to have something to do with something to do with sec squared of that function of x, but times the the derivative of the function of x. So a quick example, for instance, if f of x is ax plus b. So imagine I say y is sine ax plus b. If you want to find dy dx, the first thing you know to write down is the cosine of that function of x, so cos ax plus b, and then you just need to multiply by the derivative of the function. Now if your function is ax plus b, differentiating that gives a. So I'll just make that clearer. If we have ax plus b, for instance, and you're trying to differentiate with respect to x, you know that, well, let's see, ax, same thing as ax to the 1. So that's a times 1 times x to the power 1 minus 0, and 1 minus 1, which is 0, plus the derivative of b, which is a constant. When you differentiate a constant, you get 0. So what we have is a times x to the power of 0, x to the 0 is 1, so this is a, which is why a is there. If you know your differentiation well, then this would have made a lot of sense. Moving on. So now you know everything you need to solve problems that require you to differentiate trigonometric functions or products of trigonometric functions or products of quotient of trigonometric functions or trigonometric functions or other functions. The whole point is now you know everything you need. Let's just go through these examples and you see what I mean. So we need to differentiate 3 functions. The first one is y is equal to tan 5x. Okay. Now I'm still going to use the composite function approach, and you see why. I'm going to say let u equal 5x, which means that y is now tan u. and that means that dy dx, because this is y as a function of x, so differentiating this function requires us to find dy dx, is going to be equal to dy du, so differentiating the result of differentiating this function, times du dx, the result of differentiating this function. So what is dy du? Well, if you remember, if y is tan x, dy dx is sec squared x. So if y is tan u, dy du is same thing. It's pretty much same thing, sec squared u, times du dx. If u is 5x, what's du dx? If you differentiate 5x with respect to x, you get 5. So the result is simply 5 sec squared u. Now to part 2. Here, k is a constant. I'll just make that clear. So we have y is equal to k cos 3x plus 2. I'm going to use the composite function approach as well. I'm going to let u equal 3x plus 2 so that y is equal to k cos u. So dy dx is equal to dy du times du dx. So what is du dx in this case? Du dx is equal to 3, the derivative of this expression, and dy du is equal to the derivative of k cos u, which is minus k sine u, and I'll explain how shortly. So if you think about this, let's assume, well, you can think of what I want to do now is just make it easy for you to understand how this was differentiated. And you can think of this expression as the product of two functions. So let's say we're going to use the product rule, and from the product rule you know that, so that's how we find dy du from the product rule. You know that what you do is you take, so this is the first function, even though it's a constant, it's a function of x, because you can think of k as k times x to the power of 0, so it's still a function of x. So you can think of this as the first function, and you can think of cos u as the second function. I do not want to use u and v because there's already a u here and it'd be confusing. But the whole idea of the product rule is that you take the first function and you multiply by the derivative of the second function. What's the derivative of cos u here? So we're differentiating with respect to u now. We're looking for dy du. So if you differentiate cos u with respect to u, you get minus sine u, because if you differentiate cos x with respect to x, you get minus sine x. So if you differentiate cos u with respect to u, you get the same thing, minus sine u. The only difference is u is now x. And then the product rule, you add this to what you get when you take the second function, cos u, and multiply by the derivative of the first function. In this case, the first function is a constant. The derivative of a constant is 0. Cos u times 0 is going to be 0. So dy du is equal to minus k sine u, which is what we have here. Which means that dy dx is just simply a case of multiplying dy du times du dx. So dy dx is dy du, which is this, minus k sine u, but instead of u, I'm going to replace it with 3x plus 2 times du dx, which is 3. So the result is minus 3k sine times sine 3x plus 2. The last function we need to differentiate is y is equal to sine squared 4x, which I'm going to rewrite as y is equal to sine 4x squared. And I'm going to use the composite function approach. I'm going to break this down into two simple functions. I'm going to say let u equal sine 4x and of course that means that y is equal to u squared. So to find dy dx, which is what we're interested in, I need to find dy du and multiply it by du dx. So what is dy du? Dy du, I'm differentiating u squared with respect to u. That gives me 2u. The same thing as differentiating x squared with respect to x. In case the u is confusing, eventually you get familiar with it. If you have y is equal to x squared, dy dx is 2x. If you have y is equal to u squared, dy du is 2u. Similar result, or the same result. For du dx, we need to differentiate sine 4x with respect to x. And at this point, I'm just going to move on to this side. So this is rough work. And I'm going to, for the sake of being consistent with notation that you're familiar with, is the same thing as saying you have y equals sine 4x and you want to differentiate sine 4x with respect to x. And the approach I'll use is to say let u equals 4x and let, which means that y is sine u, so that dy dx is equal to dy du times du dx. Dy du, what do you get when you differentiate sine u with respect to u? Well, you get cos u. Similar to differentiating sine x with respect to x, you get cos x. And then du dx is just differentiating 4x with respect to x, which is 4. So that gives 4 cos u, which is 4 cos u is what? 4x. So the meaning of this is that when you differentiate sine 4x, because y is sine 4x, so if you're differentiating y with respect to x, you're differentiating sine 4x with respect to x. Differentiating sine 4x with respect to x gives this. So now back here, we're differentiating u with respect to x. U is sine 4x. So differentiating sine 4x with respect to x is the same thing as I did here, and that gives 4 cos 4x. And this is equal to 8u cos 4x, where u is sine 4x. So it's 8 sine 4x times cos 4x. Now, instead of going through the laborious approach I just went through, you could just use the result I showed you earlier, which says that if y is equal to the sine, I'll just go to the table, actually. But if y is the sine of a function of x, the derivative, dy dx, is equal to the derivative of that function times the cosine of that function. So in this case, we're trying to find du dx. And that was sine 4x. U was sine 4x. So u was sine 4x. So du dx, the derivative of y with respect to x, in this case, the derivative of u with respect to x is equal to the derivative of the function. So what's the derivative of 4x with respect to x? It's 4 times the cosine of the function of x, which is what we got here. This took less time. So I've just shown you, by showing you how fast this approach is, you will appreciate this, the fact that I told you to remember this. So I'm referring to this table where you have the sine of a function of x, if you're differentiating. If you have y is equal to, if you have a function, which is of the form, the sine of a function of x, if you want to differentiate it, you have to differentiate that function with respect to x and then multiply it by the cosine of the function, which is what we just used. So the derivatives in this table are very useful. So the final example, these are actually easier than the first ones. In this case, we have y is the tan of ax plus b. So I'm going to say let u equal ax plus b, which means that y is the tangent of u. So what is dy dx? Well, it's dy du. If y is tan u, what's dy du? Well, differentiating tan u with respect to u gives sec squared u, just like how differentiating tan x with respect to x gives sec squared x. So times du dx. So differentiating ax plus b with respect to x, that gives a. So the result is a sec squared u, which is a sec squared. What is u? Ax plus b. So I'll just make it clear, because I didn't make it obvious, that a and b are constants. Now to 2. Here you just need to apply the product rule. We have two functions. So y is u v, where u is x squared and v is sine x. I'm sine 2x. And the derivative of y, so dy dx, is equal to uv prime plus v u prime. So what is u prime? U prime, du dx, differentiating x squared with respect to x gives 2x. What is v prime? Differentiating sine 2x with respect to x gives, well, you first differentiate the function, because this is of the form of sine of a function of x. So when you want to differentiate this, you first differentiate the function of x, which is 2x, to give 2, and you multiply by the cosine of 2x. So in short, dy dx, which is y prime, is equal to u times v prime, u times v prime, so x squared times 2 cos 2x, which is 2x squared cos 2x, plus v times u prime, v sine 2x times u prime, so 2x times sine 2x. And that's all. And finally, the last function is y is equal to, we need to differentiate y is equal to sec ax plus b. Okay, so I'll just write that here so I don't forget. Okay, now if you know that sec x is 1 over cos x, you can easily deduce or tell that sec ax plus b is equal to 1 over cos ax plus b. So, and of course this is the same thing as cos ax plus b raised to the power of minus 1. If you remember from indices, the laws of indices, 1 over x is equal to x to the power of minus 1. So 1 over x is x to the power of minus 1, or 1 over x to the power of n is equal to x to the minus n. So in this case, you can think of this as x, so it's 1 over x, and then this is x to the power of minus 1. It's the same form. So in that case, y is this. And if I say let u be equal to ax plus b, so I'm using the composite function approach because this looks really messy, and I'm going to break this down into two simpler functions to make the differentiation easier. If you use ax plus b, this means that, if u is the cosine of ax plus b, then y is equal to u to the power of minus 1. This is simple. We can easily differentiate these two functions. So, what is dy dx? Dy dx is dy du times du dx. Since y is u to the power of minus 1, what is dy du? Well, dy du is minus 1 times u to the power of minus 2. What about du dx? Well, we have cos ax plus b, so we have the cosine of a function of x. So to differentiate this, you first differentiate the function of x, which gives a, and you multiply it by the sine of the function of x, ax plus b, and of course there was a minus sign, and this gives a, what is u? U is cos ax plus b, so cos ax plus b to the power of minus 2 times sine ax plus b. You can leave it like this, or you can just rewrite it as, so dy dx is a sine ax plus b over cos cos squared ax plus b. I'll explain that briefly. So cos ax plus b all raised to the power of minus 2 is the same thing as 1 over cos ax plus b squared, which is the same thing as 1 over cos squared ax plus b. So this is cos ax plus b all squared. And if you remember from the laws of indices, so what I'll just erase that. Cos ax plus b all squared. And I remember from the laws of indices, 1 over x to the n is the same thing as x to the minus n. So 1 over x squared is the same thing as, or rather, x the other way around, x to the minus n is the same thing as 1 over x to the n. So x to the minus n is the same thing as 1 over x to the n. That's what I've used there. And if you realize that and accept it, then you can easily agree that this expression is this, because all I've done is replaced this with this.